Hey, this is Don once again, owner and principal of Padlock Technologies, here to talk about a brief topic. We're actually going to change subjects here and go to SD-WAN. Now, I know I talked about SD-WAN in terms of SASE and mixing the two together and having a secure SD-WAN, but I kind of want to go into a little bit of a deep dive of what SD-WAN is, um, where you should use it at, why it was even created compared to the old way of doing, WAN technology. So let's go back in time because I'm an old guy, and let's go to the history of WAN topologies that we would create. Now, I'm not going to go way, 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 way back to like PPP and stuff like that. I'm kind of going to start with a couple things. So the first thing we're going to start with is how did we do it in the past compared to SD-WAN and sort of some of the things that we are doing now. So there were a couple flavors, how you would say, of doing SD-WAN, quote unquote. You had DMVPN, and in there was 1, 2, and 3. And 3. Then there's Flex VPN, which is just phase 4, if you want to call it that, but it's technically not a phase. Then we had the dreaded IWAN. And if every time I mention IWAN, I think fairy loses its wings or something, because if you are an old person like me, an old dinosaur like me, trying to do IWAN, which was intelligent WAN when it first came out, was a pain. I'm so glad Cisco got rid of that. So if you look at these three technologies, and we're just going to X out IWAN to begin with, because that was just a pain in the butt to try to implement. So I'm not even going to talk about IWAN. I just want you to know that that was there. So from a topology perspective or configuration perspective, you would have, and this goes for Flex VPN and DMVPN. The only difference between DMVPN and Flex VPN is DMVPN was really IKEV 1, and then Flex VPN was IKEV 2. Now, you can still do IKEV 2 with DMVPN. Just takes a little bit more configuration, but if you want to differentiate the two, just start with that first. The second difference was this was MGRE tunnels, right? And this multi-point GRE tunnels. And this actually uses this thing called a virtual tunnel or virtual interface, right? And you would use a template to do that. So that's the difference fundamentally between the two, but there's still you can do a lot more with Flex VPN because you can actually tie in AAA and stuff like that to authenticate the routers. Barring all that, though, you would typically have your dual hub design. So you'll have hub 1, hub 2, and then you would have the internet, and then you have your sites here. And what basically would happen is it would create these tunnels, automated tunnels, to each hub, right? And then when the spokes wanted to do spoke-to-spoke communication, they would do spoke-to-spoke communication. Now, they only did that with phase 2 and 3, right? And then obviously with Flex VPN, it was the same thing, but it would establish different virtual tunnel interfaces between the two, and then you would have your adjacencies on that. Phase 1 was not spoke-to-spoke tunneling because everything would have to transit the hub. And, you can bottleneck traffic here if you do phase 1. If you did phase 2 was different, especially when it came to what kind of protocol you were running underneath that, because with OSPF, you would have to make sure you're in a broadcast network type so that you can get the next hop information. And then on ERGRP, you would have to do, don't quote me on the claim, no split horizon. You had to do no split horizon and no next hop self, so that you would know the next hop of a route, and then you're going to have that dynamic tunnel. Now, phase 3 didn't really care too much about that because they had this protocol here called NHRP, or next hop resolution protocol, that would actually be doing the mapping from the tunnel interface to the NBNMA, which is basically the public IP address. That would do the mapping for you. So you would basically, from a traffic flow perspective, let's see, what color did I not use? So we're going to use white again. So from NHRP, if you wanted to talk to this spoke here. The first packet would go to the hub. The hub would send back, hey, you resolve it yourself, right? You resolve the private to public IP mapping for the tunnel interface, but it would also send a packet to the remote site that you wanted to actually communicate with and say, hey, site 1 router wants to communicate with you. You need to tell him what your private to public IP address or MBMA address is. And then that would happen between the two. That would be a reply. And then once this router would get the resolution, that's when spoke to spoke communication would happen. In a nutshell, same thing with Flex VPN. You're doing the same thing. NHRP would do the resolution, and then you would create another virtual tunnel interface. You would actually look in the routing table, and it would say virtual access as the interface, and that was the virtual tunnel. It would create a virtual tunnel based on the template that you created, and then the spoke to spoke would happen. But again, the advanced features of Flex VPN is you can add AAA to it and a whole bunch of other policies and stuff like that to it. IWAN, I know I crossed it out, was basically you would do DMVP tunnel and then you would try to put some type of intelligence on there, right? So you would try to put some type of intelligence on there. This is where you were worried about like jitter, latency, stuff like that. And then depending on jitter, latency, or any other thing that you would configure, it would kind of do automated traffic steering to the best transport based on these values that are these measurements that you're looking for. The reason why that didn't work because it was a whole bunch of technologies put on top of each other, and it was just cumbersome, and it didn't take off the way it should. So this is where you used to do it in the past, right? Most people are still doing, that I've seen in the field, they are still doing DMVPN. They're not really doing Flex VPN because a lot of people don't even know Flex VPN exists. So they're really doing DMVPN with MGRE tunnels. Is usually going to be phase 3. And then from a Flex VPN perspective, I've seen a couple people do it, but because most of the people I run into don't know about Flex VPN, they don't really run it. So the most you're going to see in the field is DMVPN phase 3. That's how we used to do it in the past. Now, what's the cons of this? Well, the big con of any of these is per box routing and management. So this per box routing and management mean it was a separate, hopefully you guys don't hear my dogs, by the way, a separate CP, control plane, and management plane per box. So routing on site 1 would be different from routing 2, then routing 3, and then the 2 hub sites, hub 1 and hub 2. The issue with that is anytime you have a distributed control plane, distributed management plane, you have misconfiguration that will eventually happen, especially if you have a big team and one person does router 1, the next person does router 2, the next person does router 3, somebody configures the hub 1 versus hub 2. Once you start doing that type of stuff, it's ripe for misconfiguration, right? And then the person ends up leaving and they didn't write down any of the configurations or what they were doing. You end up with a situation where, I don't know, you silo a lot of this stuff because, I don't know what that person did, right? I don't have the recent configs. I don't even know why they did it that way. You might configure it one way compared to somebody else. So that's one of the biggest problems, right? And on top of that, there's no such thing as ZTP, zero touch provisioning, in any of this. I mean, if you want to call, pre-configuring something in Notepad++ or Notepad and then dropping it into the router, I mean, that's primitive ZTP, but it's not ZTP like in secure SD-WAN. So how do we compare this to SD-WAN? So SD-WAN, there's a couple of things here. So at the top of the SD-WAN architecture is vManage. Right? vManage is basically the management plane of the whole architecture. So it's still the same architecture from a physical standpoint, but it's broken out in different things. So the next thing in the architecture is what they call them controllers now, but they used to be called vSmart. Now think of these as BGP route reflectors. This is your routing plane or your control plane. But I always say they're like BGP route reflectors because you can do all your policy on here. You do all your policy, route manipulation and stuff like that, and then you push it from the controllers to the C edges or V edges if you're still using Viptela physical boxes and stuff like that. But this is the control plane of the whole architecture. Then you have I usually have this off to the side. You have this thing called a orchestrator or VBond. Now this is responsible for onboarding the edges into the fabric. All right, this onboards stuff into the fabric. So what does that mean? We'll get to it when we start talking about the last and final component, which is C edge, V edge, and this is the data plane of the entire architecture. So this is where rubber meets the road. Packets go through the data plane, such and such and such. Now, getting back to that orchestrator or VBond, what happens is when you do the initial configurations on your C edges, because you got to do like a bootstrap configuration, what's up happening is it goes and authenticates with the VBond. If you don't authenticate with the VBond, you basically can't get into that fabric. Now, there's multiple ways you can authenticate. Cisco kind of gives you a certificate. There's certificate-based authentication, first of all. So this was going to authenticate via TLS because there has to be a certificate on the box that needs to be trusted by everything in this architecture. Now that can be a public CA, like I think it's Symantec that they give, or what I've done for people and what I've seen people do is they can use their internal PKI and authenticate this entire system from the vManaged controllers and VBond and V edges using the same internal PKI certificate or internal CA certificate, and then they don't have to worry about using the Symantec cert. They put Symantec in because it's easier to use to get started. But if you really want to control this from like edge to edge, if you do it yourself, right? If you do it yourself and you have the vManaged controllers and VBond in your own internal environment to control your SD-WAN deployment, then you can use your internal PKI. If you get Cisco to put it in the cloud for you or have it in the cloud, which is basically it's in AWS. I don't think it's in Azure. I don't think they do Azure for it. But when they do SD-WAN in the cloud or the controllers in the cloud, you're basically, these components are going to be in AWS. So it authenticates via the onboard process, which is I need to connect to authenticate with VBond via my TLS certificate. And let me put cert here. Certs. And then what ends up happening is the VBond will then send each C edge, hey, here's the vManage, and here are your controllers. Now, here is something that you need to look out for, and I got burned on this a couple times, but here's the thing you need to look out for. In the documentation, they say the only thing that really needs an external IP address is the VBond. That is not true. That is not 100% true. That's not even true in the slightest, actually, because what ends up happening is when the VBond sends the C edges the information on the controllers in vManage, they send whatever IP address that it communicated on. And what does that mean? So now that we got the architecture, I'm going to tell you exactly what that means. So they will tell you that if you have a firewall, let's just say firewall, because most people are going to do this behind the firewall. So if you have a firewall, and this is not in the cloud, so it is a firewall, and then you have vManage and then a couple controllers, and then you have VBON, or the orchestrator. Well, what ends up happening is they will say, well, VBON is the only thing that needs an external IP address. So even if these were all external or internal IP addresses, the VBON would have a NAT address that will go to VBON, right? So I have a NAT address that will go to VBON. Problem with this is, let's say we got some C edges here. When they go to connect to the VBON via this NAT address, when they connect and authenticate, what VBON will do is it will send the internal IP addresses of the controllers to each of these C edges. And as we all know, internal RFC 1918s are not routable on the internet. So what ends up happening? These boxes end up never being able to be managed because it's looking for an address that it can't technically route to. So, and that's in the documentation. And I got burned on this a couple of times. So what you actually have to do, there's two ways you can do this. And I'll get to the next screen. You can either do this design, which is firewall here, VBON on the outside, right? Then you got vManage and controllers on this side. They get netted to a single NAT, to a one-to-one NAT, so one-to-one NAT for each VBON and controller. This has a public IP address on the outside, right? Those two communicate like this because when you go to attach the VBON, you're going to use the public IP address and not the internal IP address. Now, you may be able to get to the VBON from internal, like say there's a switch back here. You can get to it from the internal. And then, when your C edges or V edges, if you want to call it that, when they actually connect to the VBON via public, the VBON will send, the VBON will send the external IP addresses of the vManager and controllers to the C edge. So now what ends up happening is the C edges will now be able to communicate to the controllers in the VBON via its public IP address, because that is what the VBON is going to, or the orchestrator is going to send to the V edges. That is a key difference when you do this on your own. If you set this up by yourself, if you do it where you have the VBON is the only thing that gets a public IP address, but it connected or it joined the cluster via its internal IP address to the vManager and controller, well, that's the addresses it's going to give. So just look on that. Now, design number 2 is you end up having 2 firewalls. If you're just concerned about giving raw access to your orchestrator, because that's really the key of onboarding all your stuff to the fabric, you would have 2 firewalls and then a switch in the middle. All right, switch in the middle, obviously internet in between all this, whatever. And then you'd have your vManager on this side, controllers on this side. And the reason why you'd have 2 firewalls, or you'd have a virtual router in the same firewall, is because they need to have unique. They need to be able to do basically hairpinning in the same subnet. So when you have your router up here somewhere, and then you have your VBON over here, and then each of these will get a NAT address, right? And then they will communicate like this to talk to each other. And then you could just specify on for your NAT, like your internal rules, or your rules will say, okay, you can only communicate for a certain port, something like that. But at least you're not giving raw internet. Like you don't have your VBON just automatically open to the internet, like on the first design. And then the communication is still the same. So you have your C edges. Two, and then CE1. Same thing. I communicate the VBON through the NAT address. VBON tells me, hey, the public you need to connect to the public IP address for each individual component. And now you're managing your cluster perfectly fine. I mean, I got burned on this so many times, it was ridiculous. So you definitely have to look out for this when it comes to design. Now, why would you even implement SD-WAN in the first place? Well, first things first. You are removing, it's now one control plane, one CP, and management plane, right? It's going to be multiple data plane because of the C edges, but it's one CP, one MP for management plane. All your administration for your fabric is now in your vManage. Now you can also cluster these as well, and you could do multi-tenancy if you wanted to do that as well in the vManage. And then from a CP perspective, you can just, if you did something like multi-tenancy, you can have multiple vSmarts or controllers and expand laterally just infinite amount of C edges at that point. Infinite amount of customers, infinite amount of C edges, right? But you're removing the management plane capability and the control plane capability off the box. So it's no more separate control plane based on configurations and all this other wild stuff that ends up happening when you use a distributed environment. The other thing is, authenticating when getting to the fabric. So no more, random people jumping on your fabric because they kind of got your configurations. Nope, they need to actually authenticate to the fabric now. So it's more secure. Okay, to fabric, which increases so increased security. Increased security. What's another benefit? You can add on secure access, aka SASE, and then that will equal secure SD-WAN, right? Which gives you the firewall capability. So this gives you like the firewall capabilities, ZTNA if you wanted to use that, SSL decryption, SSL decrypt. Gives you all that features, right? That stuff doesn't come, by default with traditional SD-WAN, but if you put the SASE product on top of it, you get all those features in there, right? And then of course those are the main benefits. Are there cons? Yeah, they're kind. The one is single point of failure here when it comes to CP and MP. That stuff goes down. Data plane will work, but you can't make any changes like with everything, right? Then it becomes a pain in the butt trying to restore your vManages and stuff like that. So you got to make sure that stuff is protected. What else? I mean, SD-WAN, I wouldn't say it's fairly new now, but experience of your team to try to learn how SD-WAN works, that becomes a problem, right? They have like 50 other things they need to manage. Learning another thing they need to manage is probably not going to be something on their list. Even if you force them to do it, they're not going to be well versed in it because they have other things to do. This is where I'm going to drop a plug here, co-manage SD-WAN services from someone like my company. We can definitely get this put in your environment and then manage it for you, or co-manage it for you, kind of teach your guys how to kind of do the level 1, level 2 stuff. And then when the level 3 things, or if you got to make some type of escalation, it can come to us. We can help you do a whole bunch of other things. So that's another con. Now, another benefit as well that I did not just bring up, and I can't believe I totally forgot about this, is zero-touch provisioning. So you can kind of create a template for devices, and then when they come online, it will provision all that stuff for them without you touching it. Right now, obviously, there's some front end work that you got to do, but once that comes on, it's going to be based on the model and stuff like that. Once you create that template, that comes online, instantly, provisions the switch, onboards it to the fabric, provisions with all the things that needs to be provisioned, and then bam, you're off to the next device. Do I see a lot of people doing ZTP? It depends. It depends how big the organization is. If the organization is super big, you definitely want to take care of that, or you want to do that capability, because you don't have time to be manually creating templates all the time, right? That's another benefit. Templatize configurations. So case in point, you can have, if you have a bunch of routers that are basically the same model with the same configurations, they just need to change their variables a little bit. You can have that same configuration with variables, right, that you define, and then as those things get onboarded, as those routers get onboarded, you can just change the variables, and boom, you're up and running within like 5 minutes. You just got to push the template to the device, and that's most of the time what I see is people just using the templates. They're using the form templates because there are two different templates. There are CLI templates, and then there's form templates. Now, form templates are basically in the GUI. CLI or CLI commands that you can't really type into the router, because once it's controlled by vManage, you really can't type it. You can't really do any configurations from the CLI. So that was a brief, very brief. This can get really deep if you really want to get into it, but this was a brief overview of SD-WAN, some of the components, the pros and cons, the one thing you need to look out for if you're trying to deploy this in your own environment by yourself on-prem and not using Cisco Cloud, which is basically putting all these components, or at least the management and the controller and the orchestrator, that's going to be put in AWS, and then you got to manage it from there, or they can manage it for you. But if you're doing it on-prem, you have to worry about, hey, that one-to-one NAT and things being needed public IP addresses, because if they don't, you're not going to have a fabric, because we can't reach the components that we need to reach from the CS perspective. If you need something like this, you need help on your next infrastructure project. Could be SD-WAN, could be firewall, could be ICE, could be SASE, Cisco Secure Access, could be any of that. If you need help on any of your next infrastructure projects, I'm going to leave a link in the description to a discovery call. Basically, it's not a sales call. I don't know what you're doing, so I can't sell you on the call. I have to see where you're going, and then I have to see where you're at to tell you how to get to where you're going. Once again, that discovery call link is going to be in the description. Hopefully, we can get a project. If not, you learned something today. Hopefully, this video was informative. Thank you, and have a nice day.